Truss is a rigid member structure composed of number of members. Can sustain static and dynamic loads without relative motion to each other. For example, this one is a truss structure. These all are the members. These members are linked by pin joint. It may be welded or pinned in. This one is a truss structure. These all are called members, and two members are connected by joint. It may be a pin joint, welded joint, or hinged joint. This one is member. Now this truss structure should satisfy the equation m equal to j minus 3. For a perfect structure, it should satisfy this equation. Number of members should be equal to 2j minus 3. This j is joint, m is member. Let's see the type of trusses. Plain truss. In plain truss, number of members lies in a single plane. Second one is rigid truss. Rigid truss. This truss do not collapse under load, do not deform while applying the load. Simple truss is a truss. It is constructed by a simple triangles, by adding triangles. This one is called simple truss. This truss is constructed by number of triangles. Let's see the classification of trusses. This truss is generally classified into two categories. First one is perfect truss. Second one is imperfect truss. This perfect truss do not collapse under the load. This imperfect truss unstable while applying the load. Unstable and collapse. This perfect truss definitely satisfy the equation m equal to j minus 3. This imperfect truss will not satisfy the equation 2j minus 3. It may be greater than, it may be less than. Further, this imperfect truss classified into two categories. First one is redundant. Here in redundant, number of members will be greater than 2j minus 3. Let's see one example. In this structure, number of members are 1, 2, 3, 4, 5, 6, and joints are 4, 8. So 4 into 2, 8, 8 minus 3, 5. So this one is example for redundant structure. Second one in imperfect structure is deficient structure. In deficient structure, number of members are less than 2j minus 3. One example is here 1, 2, 3, 4 members and joints are 4. 4 into 2, 8, 8 minus 3, 5. So number of members are less than the number of joint minus 3. So this is example for deficient structure. Let's see one example for perfect truss. Here members are 1, 2, 3, 4, 5 members and joints are 4. 4 into 2, 8, 8 minus 3, 5. So number of members equal to 2j minus 3. This one is best example for perfect truss. Next, analysis of truss. While analysis of the truss, we should follow some assumptions. First one is all the structures are perfect structures. That is, members is equal to the number of joints minus 3. Frame is loaded only at the joint. Load is applied only at the joints. Frame weight is negligible unless otherwise it's taken to the consideration. These three assumptions should be followed while solving the problem. There is two methods for the solving. Let's see that. This truss can be analyzed in two methods. First one is analytical method, second one is method of section. This analytical method is also called as method of joints. This method is also called method of moments. In analytical method, in two steps we can solve. First we should draw the free body diagram for each joints. Then we should apply the equilibrium equation. In method of section, first step, it is used to find the forces in the few member. We should draw the cut sections and we should apply the moment. There is some conditions to do this for a method of joints and method of section. Let's see the example for analytical method. This one is truss structure. Load is applied here. Here is reaction 1. Here is reaction 2. And this one is force F. We can resolve and we can apply the free body diagram for R1. A, B, C. Here will be the force F, B, C for joint B. Like that we can draw for joint C. This one is force R2 and here will be the force FBC and here will be the force FAC. For joint A, we can draw force FBA, FCA and F. This one is joint A. Like this, we can draw the free body diagram for individual joints and we can apply the equilibrium equation summation of Fx equals 0, summation of Fy equals 0. So we can find the forces in the each member. The condition is more than two unknown forces should not be in every joint. Then only we can apply this method. In method of section, for this structure we can do like this: R1, R2 and force F and joint A, B, C. We can draw the parting lines like this or like this. So we can take the moment here and apply the equation summation of F of x equal to 0. Horizontal force is 0. Summation of F of y equals 0 and summation of moment is equal to 0. Suppose in any joint positive and compressive force is negative, we should assume the direction. Suppose the value is negative, that indicates the taken direction is wrong. Let's see one example for this. There is a truss structure, each members having 3 meter length and incline is 60 degree. There is two load is acting. One load is at joint B 2 kN, joint C 4 kN, and reaction is created B and A and D because in these two ends it is supported. So now taking the moment 4 into 4.5 plus 2 into 1.5, so we'll get RD equal 21/6. So RD will become 3.5 and RA will become 2.5 kilonewton force. Here RA is 2.5, RD is 3.5. First let me solve in method of joint. Take the joint A, RA. Here the point A, the force will be FAB, FAE, and this is inclined 60 degree. We can resolve this into two components. Now assume the direction like this. Now summation of Fy equals 0. So Ra is equal to Fab sin 60 Fab cos 60. So Fy equals 0, Ra equal Fab sin 60 sin 60. Now we will get the value of Fab equal 2.887 kilonewton. So here the Fab is a compressive force. Our assumed direction is correct compressive force. Summation of f of x is equal to 0. So we'll get the forces here Fab sin 60 and Fae. We assume both are in same direction. So Fae plus Fab cos 60 equals 0. We know the value Fab. Let's substitute here. Fae equal minus 2.887 into cos 60. This will come as a minus because it's going in that side. So substitute the value. We will get Fae equal minus 1.44 kilonewton. Here the answer is minus, so our assumed direction is wrong. Here will be the force in tensile force. Let's go for the joint D 3.5. Here FED, FCD. Let's assume the direction. This one is tensile force because here is tensile force, so this joint also it will create tensile force. So assume direction like this, and this one is compressive force. Angle is 60 degrees, so we can resolve into two component, FCD sin 60 and FCD cos 60. Don't confuse with these two directions. This FED will create the force in this member, and this force will create compressive force also in joint D, because this one is inclined force, so it will create two forces in vertical and horizontal direction. Now 3.5 is equal to the FCD sin 60. FCD sin 60 equal 3.5. So FCD equal 4.40 kilonewton. This one is creating compressive force at joint D. Go for joint B. In joint B there is forces. Here the forces are, this one is point B, A, E, C. So the force in this member is FBC, FBE, FAB. Now summation of F vertical force is 0. We can resolve this force FAB sin 60. This will create two force, and this will create two force. Now these two force in vertical direction, and this vertical force is acting, so this angle is 60, this also 60. This will become F cos 60, F sin 60. This one is cos 60, this one is sin 60. Here the angle is cos 60, sin 60. Horizontal force is equal to 0. So here FBC equal FBE cos 60 plus FBE cos 60. So we will get value of 1.73 kilonewton of compressive force. That is FBC. Next, let's solve method of section. Now let me draw the line section 1 1. So now take the moment from here, this 60 degree, take moment at E, F A B sine 60 into 3. This length is 3 because all members length is 3. F A B sine 60 into 3, that is equal to RA into 3. RA is 2.5 into 3. We will get FAB is equal 2.887 compressive force. Draw the line here, section 2 2. Now take moment at E for section 2 2. Now take the moment at point E, F BC, this 60 degree we can draw in two component. This one is sine 60, FBC cos 60, we can resolve into two component. So now FBC into 3, FBC sine 60 into 3, 4.5 kilonewton. Same this way we can draw the section 3 3, and here we can draw the section 4 4, and we can find the values of force in each member.